Hey everyone, welcome to the new lecture of this data science and machine learning lecture series. I welcome you all, and in this session, we are going to talk about exploratory data analysis. So far, we have seen the individually numpy, pandas, visualizations, and in this session, we are going to combine that, and we are going to learn how to do mandatory pre-processing and exploratory data analysis before doing the machine learning task. So let's get started with this lecture.
Okay, so let me start with the new notebook. So in this today's lecture, we'll see how can you read a new a data set and do all those necessary pre-processing and exploratory data analysis thing needed, right? So I'll just EDA. And so let me just start with reading a new data. So for that, I need to bring the new data. So I'll just bring some new data into the current working directory. Okay, so I have got few data sets here: adult data, fuel consumption, iris to CSV. So I'll show you how can you simply read them, start using it. So let's first, just import all the necessary things that we needed. So we have imported all those necessary modules, and then we can simply read the data. Let's say df is equal to pd dot. So do you even remember the method that we through which we read the CSV file? Yeah, read CSV is the method actually. Read underscore CSV, and I can pass the name here. Let's say I'm working on iris data, iris CSV. Now if you see, so there I have got the. So basically, you can see here, this data set is nothing but the data set of flowers. There are four parts of the flowers: the sepal, petal. So basically, sepal and petal, and we are looking into the length and width of these two things. So we've got sepal length, sepal width, and petal width. You see, this one is the sepal length, this is sepal width, this is petal length, this is petal width, and these are nothing but the columns. All of them are in centimeters and their corresponding species. So by looking into the data set, let's say I'm going to predict the species, tell me whether it is a classification data, data for classification or regression. The output itself is not continuous. If you want to see how many unique values are there, you can simply say df dot species. This is how you will fetch one column. And if you want to see dot unique, so you'll be able to see all the unique values. Not only this, if you do df dot series species and dot value counts, you will get the values, how many times they are appearing. So iris tosa is 50, versicolor is 50, virginica is 50. And if you check the length of the total data set is nothing but 150. That means 150 rows and 6 columns, right? 4 columns for these features and 1 column for output, and 1 column is the ID. It's nothing but the incremental number. Right. So by looking into the data set, now tell me, is there any unnecessary thing that we can delete in here? So you see the ID column is something that has no relevance with the data. Actually, it's nothing but just an incremental number giving each and every row and identification. So we can simply delete this particular column, right? So this is how you have to define, or you have to find out something like this in your data itself. So later half, I will show you the same thing with some other data as well, so that you just have a little bit of understanding, not only just on the one data. Okay. So how will I drop? So df dot drop method you might be knowing about. I'll define the axis, which axis, around which axis I want to drop it. So this is axis 1, and I can give like drop and which column I want to drop. So I can give it here IT, and if I give, let's say in place equals to true, then it will make in place change. Right now, if you look into the data frame, there is no ID column in here. Let's try to do some analytical things in this. So you have this df.info, df.info, and there you can see like the description, some of the information, basic information about the data. So you see there are, this is column name, like how many null values, non-null values are there. So all of the values are not null. Okay, they are not null. And the data type is 64, float 64, right? And you see there is one column. There is a one column. The species column has the object data type, right? So it's nothing but the string in this case. Okay, and this is all these four are floats. Similarly, you can do df.describe. There now, if you run it, so you'll get like the statistical description of the data. And statistical description, now here it is only including the numerical description, because it is now, you can see, taking only those data points which are numerical. Okay, for example, it is calculating, all those numerical values only, because the count, mean, standard deviation, minimum value, 25 percentile, 50 percentile, 75 percentile, and maximum value. Right, so it's kind of nothing but the same thing that you might have seen in the box plot, but this is also showing you the similar thing. It will not show you the standard deviation, the box plot. The box plot will not show you the count, but box plot shows everything in on a particular scale in the graph. Here it will just say you the value. Okay, by looking into this, once again you can just know the some of the basic information about the data. So this is df.describe, and here if you do, let's say, include equal to all, now it will include all those features which are categorical as well, right? So there is this species column, like it is giving you the count in that particular column, unique value, top value, and frequency, how many times they are appearing. There are three unique values and the frequency is 50 times each of them are appearing, right? So that's how you can know a little bit things about the and these rest of the things are already given here for all the numerical columns, right? And for numerical columns, will not be getting the specific, I mean the unique count, top values, or frequency. Let's say df dot box plot. If you do, you'll be able to see the box plot, right? So now same thing you're looking into figure, right? Here this, most of the value you just see here, but here you'll be looking into the comparison between each other and between itself. It's right, the scale of the data, how does the data look like? So that also tells about the distribution of the data. You can also do df.plot as well. Data frame itself has built-in plotting techniques. So let's say, yeah, there you can see, if I'm plotting it, you can see it's creating nothing but the linear plot. And this linear plot is nothing but, I told you, right, that how can you create the linear plot, right? So it's a plt dot plot, and each the last point will be connected to the previous point. Okay, so the similarly here you can see these are the 50 values for 50 values are for versicolor, and this are for virginica. Okay, that's how plotting will basically see here. What we just did, we just did df.boxplot, right? So we can actually directly do it from the data frame itself. It's not always true that you always have to do with the matplotlib. Data frame itself uses a little bit of matplotlib inside it to plot few hard things directly by their function itself. So similarly, you can simply, let's say this one you see here, the value counts, right? So if I do, let's say, I can simply do SNS dot count plot, and here I can give that df dot species column, right? So you see here, we are getting the count plot of this species value. And so there are 50 iris. So those are 50 iris for 50 iris for Zinca. It's nothing but a bar graph. Individual, unique values and count their counts, how many times they are appearing in that. Simply visualize the basic thing in the data set by looking into the correlation analysis or the scatter. For example, we have a data frame, and let's say I'm taking sepal length and sepal width, right? And then running them and showing the graph. So this is how sepal length and sepal width look like, right? So you see here the sepal length and sepal width are different features, and when I'm plotting two different features, you can see some observation in here. So we cannot look into some real observation because the data sets are very small. You can do for those as well which are having high correlation as well, right? For example, let's say scatter plot of between sepal length versus petal length. Now if you see, there is a significant correlation in this case, right? Sepal length and petal length. So if sepal length is increasing, then petal length is also increasing. You can also mark the axis as well. I have not done this, but you can do it. Okay, like you can mark the axis, like which axis is representing what, like sepal length is x-axis or y-axis, and remember the x level and y level thing. Right, you can also do the reg plot as well for the same. If I do the reg plot for this one, yeah, you can see here if I do sns.reg plot, here it will giving me the regression plot. Regression plot is nothing but with the data, it will also give the regression line along with that, right? See, if I do the same with this actually, so both of them has a very, very significant difference. Here, the trend line is showing something different. It's not showing any significant incremental or decremental of value. And also the confidence here, you see, in this shadowed portion is high, but in this, the shadowed portion is very, very less. This represents the confidence, right? And the confidence is higher in this. So we can simply say that the correlation is very, very high between these two variables. That we will see later on. How can you simply find out the correlation between two values into arrays? I'll tell you that. There is one thing called join plot, right? Let's say the same thing. If I plot join plot. So now you see here it is not only telling you the regression plot, it is giving you the regression plot, but along with it, it is also telling you the distribution of the data. Now this distribution of the data is nothing but the histogram. You see how many times a data set is appearing at one particular location. That's nothing but the histogram. So on each the opposite axis, it is showing the histogram, right? For example, this histogram, the top histogram is for sepal length for this one. This one, the right hand side histogram is for sepal width. Okay. That's how you'll be doing small things. Let's say if you want to see all these things for this particular graph or this particular graph or this particular graph for all the different combination, right? For example, as of now, you have only looked into, let's say, scale sepal length and petal length. In here, you can once again see sepal length and petal length. Here, sepal length and sepal width, right? So let's say if you do the pair plot, right? If you want to get the scatter plot for all the different combination, right? For example, you might get from sepal length versus petal length, right? Or sepal width versus petal width. So what you can do for that is simply do df.pair plot and give the data frame in here, right? If I run it, so you see what we have got. So you see this first graph is corresponding to sepal length versus sepal width. This class is corresponding to sepal length versus petal length, right? This particular thing is regarding sepal length versus sepal width. Okay, so that's what you can simply see. And the reason behind passing this, why are we getting this just one diagonal only, is because I have set corner is equals to true. If I set corner is equals to false, so it will just fill all the tables here as well. This whole thing you see here, that will be fitted by that. If I do not pass corners equals to true, let's show you and run and show you. See, basically this are the same, this are the same, this are the same. So that's why they say that there is no need to use this particular thing. Basically, it's repeating, right? So you can simply use the corners to see the values at once. For example, you might be seeing this. Why here you are getting this bar graph, not the scatter plot? So see, if you just do the same features on both the axes, so you will get a straight line, right? If you don't believe, we can just try. Just try sepal length versus sepal length. See what do you get. Sepal length versus sepal length, okay? Going to the next, so you can simply do df.corr to get the correlation value in here, right? So you see sepal length is this much, the correlation value, right? So you see the correlation value between sepal length and petal length is 0.87. It's the highest in this case, or here you see 96. So petal length versus petal width, right? So this is petal width versus petal length, and this is, so you see here this 96 values, that is having very, very high correlation. So we need to check for that. So if two features are having very, very high correlation, that means you can do the task with one of them only, leave the other behind. Okay. So df.corr, so corr will return the correlation value. So this correlation analysis, you see, you'll be able to find out the different dependencies from different variables, right? How like the variable means these columns, actually the sepal length, sepal width, okay, these features. Actually you can also do the heat map of the same. For example, if you simply do sns.heat map, and if you pass df.corr in here, yeah, so you see here df.corr is giving me this result, and in this you see there are some values which are extremely negative like this and this, and there are some values which are extremely positive like 1, like this and this. So it's nothing but the heat map. What else you can do is, let's say df.mean. So you've got the mean of all the columns, all the different columns, all the numerical columns to be specific. For example, if you want to group by species, like if you want to see the mean or the different values, alone for one particular data, so you can do that. So df dot group by and group by species. Right. And then you can use, so you might be knowing about the group by function. So according to group by function, for every group by function, there must be an aggregate function for it, right? So let's say if I choose the aggregate function as mean means the average. So you see for every group, right, in the species column, there are 3 different values, right? Means there are 3 groups. So one is of Satosa, Iris Satosa, one is for Iris versicolor, one is for Iris virginica. So for all these different values, for all these 3 values, you are getting the mean, right? For example, in this Iris Satosa, what is the mean sepal length? This is the mean sepal length, mean sepal length for Iris versicolor and for Iris virginica. Okay. Similarly, for this mean sepal width, right, you'll be able to get this. There are some other mandatory pre-processing needed into this. For example, label encoding and normalization, right? Label encoding, normalization, and pre-processing. So there is also something, for example, if you have null values, right? So if you have null values, so what you can do, you can simply use, let's say df dot drop na. Drop na is a method that will drop the null values. Like if you have enough features, so you can simply drop it. If you do not have enough features, then you have to fill it, right? For example, you do not have enough data, then you will not drop, you will fill the values. So what in that case, what you can do, you can fill the values based on the fill na method, right? For example, if you have the drop na method, here you can pass the axis, like which axis you want to drop. Either you want to drop the row or you want to drop the column. Mostly we'll be dropping the row, not the column. We'll be dropping the column if
it has a lot of null values, more than 50% of the data is null, then only you have to drop that column. Otherwise, you have to drop the rows if you have enough data. Okay. Other than that, there is something called yeah, df dot drop in, you can simply drop it. Okay. Since there are no null values, right, in this, no null values, so no issues for that. If you do df dot, there is also something called fill na method. Fill na, right? Here you will pass the particular value that you want to fill with. Like if you want to fill with the mean, the median, mod, or whatever, you can simply calculate and pass it. You can also do it column wise as well. For example, if you just take one column out of it and fill that, right? So for example, here there are some null values in the species column. So then you can compute which one is the maximum out of it, and then df dot fill na, not df dot fill na, you can simply do it for one particular column, right? Species and then fill na, like you can pass the value that you want to fill with, right? And that will be filled. Okay. And basically this this is returning, right? That means it is not changing it. Then you can simply do this way. Df dot species is equals to df dot species fill na, like this. Right now it means now it is making the in place changes. There are some mandatory pre-processing in this process. We have something called label encoding. So label encoding, for example, in this one, we have species, right? So species needed to be encoded, right? Species is needed to be encoded. So for example, for this species, how can I encode it into numerical? So anyone remember in the first lecture that I have taken for the label encoding, I had told you how can you do that? There is something called label encoding. Okay. So we have sklearn module, and sklearn module provides label encoding. So what we can do, we can go label encoder sklearn. So I will throughout this process, I will so many times suggest you to visit the official documentation, right? Official documentation will tell you how to use the code and what to use it. So for example, label encoder is something that will let you help to encode it, right? Let's say label encoder from sklearn dot preprocessing import label encoder, right? We have imported in just imported the label encoder. Now let's create the label encoder object, calling this function. Now I release that object. Now what you have to do is, let's say this is the column that you want to encode, then you have to do it one by one. Let's say if there are more than one column, then you can write a for loop for that, right? So there is another set of data that I have. I will give you after the class itself. So this one I will be teaching with. There will be another set of data that I will give you in the classroom as an extra. So there will be a lot of things done, right? For example, this fill any, drop any, everything will be there. There will be a lot of visualization, some more understanding of the data will be there. So you can also go and follow that. If you look into that, you will be able to understand better. Right. So for example, label encoder we have created now, le dot fit. So we will fit with the data. Now data is nothing but the species column. Le dot fit df of species. Okay. Now we have fitted it. Now if you want to transform, le dot transform, and once again we can pass the same data in this df of species. Right. So when I'm transforming it, see, it is returning the value. See how values it is returning. It is returning 0, 1, 2. Means the first value, it is changing into 0, right? For example, iris satosa being changed into 0, iris versicolor being changed into 1, and virginica being changed into 2. You can count, there are total 50 values of each, right? Now what we can do, we can reassign this. Either you do this way or you can directly do the fit transform here, right?
Instead of fit, you can use fit transform, this method. Then it will directly return. Okay. But I will request you to do this. Now I have updated the value of that particular column. Now, if you look into the df, so you see the values has been changed, right? Now it is numerical as. Okay. Now the thing is that, remember I told you that you need to do the XY split. XY split is nothing but, if you could recall that that first session where we had the introduction of AI, where I had told you, right? Now we need to do the XY split. XY split means dependent, independent feature. We need to make it separate, and we need to make uh, the input and the output separate in the data. Now what can we do? For this, we can simply do df of df dot drop, which column? Species column. I'm dropping the species column, right? When I drop, sorry, df dot, yeah, sorry, yeah, I need to give access equals to 1, correct? Access equals to 1. Now you see what is it returning? It is returning all the other column other than the species, right? So we can store it in something called x, right? Now similar thing we can do for y, but for y we can do y is equals to df of species, right? Now I have got values in y and x both. X is a data frame, y is a we can say a panda series. Okay. Now we have done the XY split or input output split. We can simply give it a name as well. XY split and input output split. Now we have done it. Now there is next thing that is called the test trend split. Right now you can simply go and search on Google test trend split sklearn. Right. Once again, it will lead you to one official documentation page. On the official documentation page, you can find the code snippet. Okay. There will be giving you a very small the implementation of the data. So now that you can see here, what is that? Test trend split. So now next time, I've been importing the test trend split. Now, or you can simply copy this and paste it here. Right. So you see here, I'm passing X, right? The input here, I'm passing Y. Here, I'm giving the test size. For example, text size is 30%. Random state is something that is used for the reproducing the result again. So if you use a particular random state and use it every time, it will split the same data in the same group, right? For example, if let's say third data has been gone into training, so every data point in training will again go every data point. So it will reproduce the same result every time, this random state, if any value you pass. Okay. If you do not pass, so every time you run it, it will make different split. Okay. Different data points will go into them, but the ratio will be same. Test size will be 30% of the train. Okay. 30% of the whole data. If I execute it. So now I have got something in here. Let's see. Dot shape. So you see 105 comma 4. So 4 rows, sorry, 4 columns and 105 rows has gone into this. Similarly, if you see y test, 45 values are there total. One more thing we forgot to do, that is the normalization. Now, normalization is something, in this case, that is not necessary, but yeah, that becomes important at so many different places. For example, you are looking at values like 5, 4.97, 4.7, 4.6, 6.1, so on. Let's say there is another column having values like 3,528, 4 lakh 2,053, something like that. What does it mean? It means that the values are very long in this state, in this column, right? In this column, values are very, very long. In this column, values are very, very small. So sometimes the model, when you are modeling it, it is always a good habit to bring all the data points in the same scale, right? All the columns in the same scale. Yeah, so in order to bring all the columns in the same scale, we do the normalization of the data. There are two different ways of normalization. The first one is the min-max scaler. The second one is the standard scaler. So first one, the min-max scaler is something that will always, reduce the data sets into 0 and 1. So I guess I have gone through the, theory part of it in the introductory session. I have gone through the math part of it in the introductory session. So I would ask you guys to recall and see. So let's say min max scalar learn. Min max scalar is learn. So you can also see the formula here, right? It's a very basic formula. I imported it. So I can do it here itself. Either you do it before, test and split, or you do it after test and split. Before the test and split is always okay. Doing after test and split, you'll have to think about like fitting with the training data and transforming both training and testing. That's something you have to remember that. So let's say I want to, normalize it. What will I do? Let's say ESC scalar is equals to min max scalar. Right, I've got the, sorry, to run it. So this is the scalar object. Now all you have to do fit sc dot fit and give this whole, 4 columns. Or let's do it for X here. Right, sc dot fit X and then sc dot transform X. Right, and here X is equals to, for example, here if you see X, what will you get? And here if you see X, you'll get totally different thing. Here you are getting the transformed value, the scaled value. Here you will be getting the original, this type of value. So that's how we are changing it. And you see here, this is a 2D data, 2D array, not a data frame shape, right? So now you can see here 4 columns and once again 150 rows. Okay. Test and split. We have done the test and split. We have done the normalization. So that's pretty much of it. That's what we do for any data. Okay. That's what you do for every data that you have. You will have to do the label encoding if possible. If there is any categorical feature, you'll have to normalize the data most of the times until unless your data is like this, like very, very less difference between the data, right? Or else you have to do this, right? The XY split, you always have to do the normalization, the distance split, right? The XY split, everything is totally necessary. You will have to do that. Okay. So now your data set is ready. So what we have done, we have analyzed our data set. We have understood about the data set. Is there in correlation or not? You can also do, like, let's say if somebody asks the questions, so you can answer the question by using the different things. For example, group by class, or all the other stuffs are there that you can simply do, right? And answer the question, let's say, based on any data. Let's say if the data is given and somebody asking the question, for example, what is the mean of that? What is the mean of this? What is the average age of women, average age of men? How many they are, educated or not? So if based on any given data, is based on specifically data scenario, if somebody asks the question, you should be able to answer, because there are plenty of things, right? If you know, let's say, how to calculate the mean or the average, or you can simply Google it. You'll be able to find that, right? Googling is not always, a bad thing. So that's pretty much of it. Now your data set is ready to go into the model, right? All you have to do is just understand the model and create the model. and try to feed the data into the model and train and test. So that's pretty much of it.
Thank you so much for watching this video. If you liked it, do press the like button and subscribe to the channel so that you can never miss the video. And if you want to learn data science and machine learning, do follow my data science and machine learning playlist and hype this video so that it can reach more people like you. Thanks again. We'll see you in the next one. Till then, bye bye and have a great day.